So today we're going to do finding the inverse of functions. There are 3 steps you always have to remember to do when you're solving to find the inverse of a function. Step 1 is to rewrite f of x equals as y equals. Then we're going to switch x and y. X and y are in quotations because it won't always be x. It may be n, m, whatever, but we always switch it with y. And lastly, we solve for y. So our first example, we have to find the inverse. I have f of x equals 3x minus 2. So, first things first, like step 1 says, we're going to switch f of x equals to y equals. So, it becomes y equals 3x minus 2. Now we actually have to switch x and y. That means these actually switch positions. So, y is going to come over here to where x is, and x moves over here. The 3 does not change spaces. The 3 stays in the same spot. So it becomes x equals 3y minus 2. Remember, the third step is I solve for y. So I'm solving to get y back by itself. So first thing we do to solve to get y by itself is move the 2. So we're going to add 2 to both sides. So we have x plus 2 equals 3y. Now to get y completely by itself, we have to get rid of 3, and it's 3 times y, so we divide by 3. So my answer is going to be x plus 2 over 3 equals y. However, your answer won't always look like this. Instead, they may write it this way. F raised to negative 1 of x equals x plus 2 over 3. Now, the negative 1 means inverse because it's the opposite when you raise it to negative 1 power. So anytime you see f raised to negative 1, that means I'm finding my inverse or we found my inverse. And this is how we write our answer. So, example 2. Once again, we're going to find the inverse. I have f of x equals x squared minus 3. Same 3 steps. So remember, the first step was rewrite f of x equals as y equals. So that's the first thing we want to do. So it's not f of x equals anymore. It is now y equals x squared minus 3. And remember, the second step was to switch x and y. So now x and y are going to switch positions. So the y comes over here, and x will move over here. Remember, what's attached to it stays in the same spot. So the square does not move with that x. So it becomes x equals y squared minus 3. Remember, the last step, number 3, is we solve for y. So to solve for y, first thing I'm going to do is move the number. So I have minus 3. I am going to add 3 to both sides. So I have x plus 3 equals y squared. Now, I have y squared. I want to get y all by itself, so I want to get rid of that square. And how we get rid of squares is I square root both sides. So when you square root both sides, the square and the square root cancel each other out. So my answer is the square root of x plus 3 is equal to y. But of course, that's not how we write our answer. You write it as f raised to negative 1 of x equals the square root of x plus 3. put philosophically, so I'm going to rewrite this. So, moving on to example 3. Once again, I am finding the inverse. For all these problems, it's going to say the exact same directions. We are going to find the inverse. So I have f of x equals the cube root. Now it's not a square root, it's a cube root this time. You know it's a cube root because of this right here. That tells me it's a cube root. It's raised to a power, well technically kind of the power of 3 because the 3 inside the little root. That means a cube root. So now we have to solve for this. The first thing we do is follow the same steps once again. Now, in case you forgot already, let me remind you. First step is we rewrite f of x equals as y equals. Then we're going to switch x and y. And then lastly, we solve for y. So, number 1 says rewrite. So now we rewrite it as y equals the cube root of x minus 1. And the minus 1 is also on the outside. That's separate. Do not write them all together under that cube root. It's the cube root of x minus 1, and then also minus 1 on the end. Now the second step is switch. So we switch x and y. So y goes over here, and x comes over here. So x moves to the outside of the cube root, and y goes inside in its place. So that is x equals, now the cube root of y minus 1, and then minus 1. And now the last step, number 3, we solve for y. So to solve for y, the first thing I do is move the 1. So we have to add 1 to both sides. Once I do that, I have x plus 1 equals the cube root of y minus 1. So the next thing to do is to solve for y. I cannot touch that negative 1 behind the y yet, because some of you may want to go ahead and try to add 1 to both sides. We cannot do that because they are both under that cube root. So the next thing we're going to have to do is actually get rid of the cube root. To get rid of a cube root or a square root or the 4th root, 5th root, whatever it is, we raise it to that same power that's inside that root of the square root. So because there's a 3 right here, I'm going to raise both sides to the 3rd power. Because once I do that, the cube root and the cube cancel each other out. And that's what I want. So it ends up leaving me with y minus 1 on this side. The cube root's gone. And on the other side, I now have x plus 1, and it's now raised to the 3rd power. So now, finally, to get y all by itself, what I need to do now is get rid of that negative 1 finally. So I'm going to add 1 to both sides. Now, once again, a lot of you are going to try to say 1 plus 1 to give you 2. We cannot do that because that positive 1 on the inside of that parentheses is raised to this 3rd power right here. So because it is raised to that 3rd power, I cannot add 1 plus 1. So what we do is just write on the outside by itself. So our answer is going to be x plus 1 cubed and then plus 1, which we know we write as f raised to negative 1 of x equals x plus 1 cubed, and then plus 1. So, next example. Example 4. Once again, we're finding the inverse. Same rules apply. This time it's not f of x, it's f of n. But I still do the same thing. So I rewrite f of n equals as y equals. We have 1 over n minus 2. Remember, the second step is to switch. In case you forget it, let's write it down. So number 1 was rewrite. Number 2 is what we're doing right now, which we are switching. Before it was x and y. This time I have n, so I'm switching n and y. So y is going to go down here, and n goes right here. So we have n equals 1 over y minus 2. And remember, the last step is to solve for y. So we have to solve for y, and y is at the very bottom of that fraction. Now, you may think, oh, multiply both sides by n. We cannot multiply both sides by n. We cannot divide by n right now. I need to actually get rid of, or actually move that y minus 2. It cannot stay on bottom because I cannot solve for y unless I move it to the other side. So to get y minus 2 to the other side, I'm going to multiply both sides by y minus 2. Do not distribute that n. Your instinct may be to go ahead and say n times y, n times negative 2. We don't want to do that. You want to keep them separate. So y minus 2's cancel out. So we have y minus 2 times n equals 1. Now remember, my goal is to solve for y. So I can't move 2, but I can move that n. So it's y minus 2 together, and then times n. So to get rid of n, I divide both sides by n. And once I divide both sides by n, I'm going to have y minus 2 equals 1 over n. And now the last step is easy because I have y minus 2. Thing I need to do is add 2 to both sides. So I have y equals 1 over n. Do not put plus 2 at the bottom. Don't try to put it up top at 1 and make it 3. We have 1 divided by n, and then we add the plus 2 in the back. So this is our answer. Of course, we write it as f raised to negative 1 of n equals 1 over n plus 2. So now, this week we've been talking about exponentials and logarithms as well. So of course, we have to find the inverses of those as well. So example 5, we have to find the inverse. I have y equals 5 raised to x plus 3. So now, just because it is 5 raised to x, that does not change anything. We still follow the same process. The difference is, I don't have to rewrite it as y equals. It's already y equals. So we can skip step number 1. We go straight to step number 2. So step number 2, we still go ahead and switch x and y. So y is going to come over here. X is going to go over there. So we have x equals 5 raised to y plus 3. And of course, we need to actually solve for y. Now, the way we solve for y is this. First, we have to move over to 3. But that's not attached to y. The only thing attached to y is 5. So we touch the 3 first. So we subtract 3 from both sides. So we have x minus 3 equals 5 raised to y. Now, to solve for y, I cannot go ahead and divide by 5 on both sides because I have 5 raised to y, not 5 times y. That's the difference. So I need to get rid of 5 and make y normal, because right now y is an exponent. This is where we bring in log. Now, to get rid of that 5, I need to bring in log of the same base. Because remember, when I explained to you guys exponentials, 5 is my base and y is your exponent. So to get rid of that 5 base, I need to bring in a log with base 5. So what we're going to do is write both sides as log base 5, that means a little 5 beside log, of both sides. So log of base 5 of x minus 3 equals, also on the right side, log of base 5 of 5 raised to y. Now, if you remember what we did when we actually simplified logs, expressions, then remember we said that they have the same base, they cancel each other out. So, right here, log of base 5 of 5 raised to y. 5 and 5, these are both my bases. So because they're exactly the same, they cancel each other out. And when they cancel each other out, y becomes normal. It is a normal part of your equation. It's no longer an exponent, it's just y by itself on the right side. So we have y equals log of base 5 of x minus 3 equals y. And that's my answer. There's nothing else we can do to that. We don't write it as f raised to -1 of anything. Because when you see it on your test, quiz, or whatever, they're going to have y equals instead of f of -1, or f of n, or f of x. So this is my answer. I know some of y'all may still be confused, like what just happened, what's going on. We're going to do another one just like it. Don't worry. So remember, whatever your base is for your problem, you do log of that base on both sides. So we do the same thing for the next example. So example 6. Once again, we're going to find the inverse. This time I have y equals 3 raised to x minus 8. And once again, the first step is already done for us. We don't have to do y equals, because it's already y equals. We go straight to switching x and y. So y goes over here, x goes over there. So it becomes x equals 3 raised to y minus 8. And now we have to solve to get y back by itself. So first thing we're going to do is add 8 to both sides. So we have x plus 8 equals 3 raised to y. And once again, we have to solve for y. That's the very last thing I have to do. I already moved the 8, now I have to get rid of 3. And just like our example number 5, we still have to get rid of 3 by bringing in the word log and make it the base that we need to get rid of. So it was attached to y to 3. So what we do is we put down log of base 3 of x plus 8 equals log of base 3 of 3 raised to y. And just like we did for the last example, because you have log of base 3 of 3 raised to y, the 3's are exactly the same, so they cancel each other out. So now, because they cancel each other out, I am once again left with just y. So y equals log of base 3 of x plus 8. This is my answer. So, 2 more examples to go. So, example 7. It's a lot like examples 5 and 6, but a little bit different. So, we have to find the inverse. I have y equals 5 raised to x divided by 3. Same process as we've been doing. So, first thing we have to do is not write it as y equals, because it's already there. We switch x and y. So, y goes over here, x goes over there. So, it becomes x equals 5 raised to y over 3. So this is a lot like example number 5, but it's a little bit different because I'm dividing by 3 this time. So to get rid of that 3 that's on bottom, I have to multiply both sides by 3. So I have 3 times x, which is 3x, equals 5 raised to y. It's a little bit close, so let me erase that in case I'm confused about how close it's written. I'm going to write that a little bit lower. Once again, that was 3x equals 5 raised to y. And once again, I have to solve for y by getting rid of that 5. And how do we get rid of that base 5? We bring in log of base 5. It is of 3x on the first side equals log of base 5 of 5 raised to y. And once again, log of base 5 of 5 on this side. They're both the same basis, so they cancel each other out. So I have log of base 5 of 3x equals y. This is nice. So, last example, example number 8. We have to find the inverse. This one's different because I have y equals log of base 3 of x minus 4. It's different because I have log. We did radicals, rational fractions, linear equations. Now we're doing log equations. So same steps we've been doing. So I have to first write as y, which is already there. Then we have to switch x and y. So we're going to switch y over here and x over there. So we have x equals log of base 3 of y minus 4. And of course, now we go ahead and solve for y. So we cannot get rid of log yet. We have to get rid of that 4 first. So we're going to add 4 to both sides. So we have x plus 4 equals log of base 3 of y. Now, just like for the last problem, to get rid of the bases when we have 5 raised to y and 3 raised to y, we have to bring in log of base 3 or 5 for the last problems. This time it's going to be the opposite of that. This time I have log of base 3, so I need to actually raise both sides to that base. My base is 3 for log, so I'm saying 3 raised to the first side equals 3 raised to the second side as well. So we're going to have 3 raised to x plus 4 equals 3 raised to log of base 3 of y. Now, same thing applies. Just because it's not directly beside each other, it still applies that if the bases are the same, they cancel each other out. So I have 3 raised to log base 3. Those are both still base 3. So because of that, these still cancel each other out. And once again, that means I have just y over here by itself. So our answer is going to be 3 raised to x plus 4 equals y. And that's it. So hopefully you understood everything I went over today. If not, of course, you know you can send me a message on Google Classroom, send me an email, send me a text message, whatever you need to do so I can make sure you understand this stuff. See you tomorrow.